With this video, we're going to be going over the AS Pure Paper Edexcel from May 2018. Now, what I'm going to do for each question, I'm going to start off by just showing you the blank question so you could pause at that point. Secondly, I will just give you a hint. So if you're struggling to access a question, I will just give you a few points of work solutions and talk you through that. Okay. So question one is this one on integration. So if you just want to do this with no hints, then pause the video now. Okay, so if you want a hint for this, so what I would do first of all, whenever you've got to differentiate or integrate, start off by getting ready to integrate if you like. So just make it in this format that I've done here in blue. Okay, so the 2/3 x cubed is fine, but the square root of x, just write that down as being x to the power of a half, then the added 1, and then you're just going to go through term by term. So integrate this first term, integrate the second term, integrate the third term. And remember how you integrate. You step 1 for each term, you add 1 to the power, and then you divide by the new power. And I would suggest your first line of workings after this one, just literally add 1 to the 3, okay, so make it a 4, and then divide by the 4, and then tidy it up with the third line of workings. And then my final hint, don't forget to write down your final answer with plus C with it. So the solution for question 1. So for each term we add 1 to the power, so the 3 becomes a 4 and we divide by the new power. For the second term, the half becomes 3/2, we're adding 1 to it, divide by this new power. The integral of 1 is x, and don't forget to add the plus c. So that really is just that line there, we're just following the integration process. And then finally, just tidy it up. 2/3 divided by 4 is 2/12, which is a 1/6. And then over here, dividing by 3/2 is the same as multiplying by 2/3. Okay, so 6 2s are 12, 12 divided by 3 is 4, so it's a -4. So that is our final answer. So here's question 2. So pause now if you just want to have a go at the question with no hint, or just hang on for a hint in a few seconds. So my hints for this question. So for part 1, start off by completing the square, okay? Because when you go and complete the square, that first term which is being squared by definition is greater than or equal to 0. So that's my hint for part 1. Now for part 2, just bear in mind that the number could be either positive or negative. So you need to work through and try and just come up with values that support whether it's true, sometimes true, or never true. So that's it for your hints for question 2. Question 2. So here is the final solution. So to complete the square, remember you halve the coefficient of the x as a starting point. So -8 halved is -4, hence why our opening bracket is x minus 4 all squared. Now picture what you get when you multiply x minus 4 by x minus 4. You get x squared minus 4x plus 16. Which is x squared minus 8x plus 16. But we only want the x squared minus 8x. We don't want that plus 16. So we back out that 16 with a minus 16. So basically that bit there, the x minus 4 all squared minus 16 is equal to the x squared minus 8x. And then secondly, we add on the plus 17. We then gather up the minus 16 and plus 17 to have the plus 1. In square format, we can just conclude the following. Anything squared, whatever x is going to be greater than or equal to 0. So when x is 4, we get exactly 0. For any value of x other than 4, once we've squared it, we're going to get something greater than 0. So x minus 4 all squared is greater than or equal to 0. So once we add on the 1, by definition, it's now greater than 0 because it's greater than or equal to 1. So once we've got to that, we can therefore conclude that given that this is an alternative format of what we were given, that x squared minus 8x plus 17 must be greater than 0 for all real values of x. Now for part 2, we just need to come up with a couple of solutions. So you take a positive solution, for example, x is 5. Well, 5 add 3 is 8. 8 squared is 64. And obviously 64 is greater than 5 squared. So in that case, the statement is true. However, when x is negative, for example, minus 5, well, minus 5 add 3 all squared is 4. Whereas minus 5 squared is 25. So now it's not true because 4 is less than 25. So we've been asked to give a reason if this above statement is always true, sometimes true, or never true. Well, here's a reason. We're just showing that this is sometimes true because we've shown on one occasion it's true, shown on another occasion it's not true. Question 3. So pause it now if you just want to read the question and before I move on to the hint. So remember that a position vector is the vector from the origin to A. So the position vector for A is the vector from O to A, and the position vector for B is the vector from O to B. Now I always think with these, just to help you gather your thoughts, a diagram helps. So just do a rough diagram. So the O to A is 4i minus 5j, so that's 4 to the left, 5 down. There we go, 4 to the left, 5 down. That's O to A. And O to B is 5 to the left and 2 down. 5 to the left and 2 down. Now we're being asked to find the vector from A to B, so we're going from A to B. So we're going to go from A to O, then O to B. So I'll leave it for you to work that out. And then for part B, this modulus signs here means you're working out the magnitude, so the size alone of the vector. So once you've worked out the vector for A to B in part A, which can either be an IJ format or column format, you then need to go and use Pythagoras to work out the size of the vector for part B. So the final solution for 3. So A to O is going from O to A the wrong way around. So rather than 4 minus 5, that's minus 4, 5. That's taking us from A to O. Then we're going from O to B the correct way. So minus 5 minus 2. Minus 4 add minus 5 is minus 9. 5 minus 2 is plus 3. So the final answer is minus 9a plus 3j. You could have given your answer in column format. And then for part B, we've now got to work out the modulus of this. So it's minus 9 squared plus 3 squared, the square root thereof. So that's the square root of 90. So giving your answer is a simplified surd. Remember, root 90 is root 9 root 10. And the square root of 9 is 3. So that's 3 root 10. Question 4. So here's the question. So pause now for the question alone before I move on to the hint. So here's the hint. Now we're being asked to work out whether these two lines are parallel, perpendicular, or neither. So this is obviously all to do with the gradients. So start off by working out the gradient for L1, rearranging it to get into the y equals mx plus c format. Then work out the gradient for L2. I suggest you do a quick sketch to help you do this. Bear in mind whether it's going uphill left to right or downhill left to right. Uphill will be positive gradient, downhill negative, and the gradient will be the y step over the x step. Now, once you've worked out these two gradients, if they are the same gradient, the lines are parallel. If when you multiply one gradient by the other, you get minus 1, they are perpendicular. Otherwise, they are neither. Question 4, here's the solution. So, focusing on L1 first of all. So let's add 3x to both sides, then divide by 4. We get y equaling 3/4 x plus 10 over 4. So the gradient of line L1 is 3 over 4. Now, doing a quick sketch for L2, I've got my 5 minus 1 over here. my minus 1/8 over here. I've drawn in the triangle. So my x step is going from minus 1 to 5, which is 6. My y step is going from minus 1 to 8, which is 9. So my gradient is the y step 9 over the x step, which is 6. But as it's going downhill, that's minus 9 over 6, which simplifies to minus 3 over 2. Now, clearly these gradients aren't the same, so they're not parallel. 3/4 multiplied by minus 3 over 2 does not give minus 1, so they're not perpendicular. So we conclude that lines L1 and 2 are neither parallel nor perpendicular. Question 5. So the hint is just about to come up. So this question is all about understanding the basic rules for logs. Okay, so remember the multiplication law, that log xy can be broken down to being log x plus log y. Log x over y can be broken down to being log x minus log y. And then the power rule here, you sort of take that k downstairs. So log x to the power of k is k log x. So for part A, identifying two errors. So the first thing you're looking at to do is all to do with this, the division law. They're calling it the subtraction law, but that's kind of the same thing. So the division law, and note how it's working when you've got no coefficient in front of the two logs. And then secondly, it's all to do with the second error is to do with well, I've kind of given it away over here, to be honest. It's all to do with understanding exactly how the logs work. So this hint over here might be a bit too much of a hint, but up to you whether you focus on that now or not. Question 5, the final solution. So the two faults are firstly here. You can't go up here. You can't go and use the division law until you've taken that 2 upstairs, okay? You have to do the power law before you do the division law. So I've stuck with the language they've been using. So you cannot use the subtraction law until you've dealt with the 2 first. And then secondly, you've got to realize that log x to the base 2 is actually 2 to the power of 3, not 3 to the power of 2. Now, the way I like to focus upon this, because I find it quite difficult to see this straight away, if I've got a log to the base 2 on the left-hand side like this, I like to go and introduce log to the base 2 on the right as well. And just going back to the previous slide from this rule down here, log anything to its own base equals 1. So what I like to do is to actually just introduce log 2 to the base 2 on the right hand side, because that equals 1. So I'm not changing the right hand side overall. And then I find it quite clear then to see, well, that 3 goes upstairs being the power law. So we've got log x equaling log 2 to the power of 3. So obviously x isn't equaling 2 to the power of 3 and not 3 to the power of 2 as it's said over here. So those are the 2 errors. So writing out the correct solution, our first line of working should have been to take that 2 upstairs using the power law. So we're taking that 2 upstairs. Then we can go and use the division law and have the x squared over x to the half. Meanwhile, on the right hand side, just like I was saying over here, I've introduced log to the base 2 and taken the 3 upstairs. So I can now, I've got log to the base 2, this bracket, log to the base 2, 2 to the power of 3. So this bracket here does indeed equal 2 to the power of 3. So I'm effectively, if you like, cancelling out the logs, but I'm just equating coefficients. This coefficient here must be this here. So x squared over x to the half equals 8. Obviously, when we divide, we subtract the powers. 2 take away half is x to the 3 over 2. So multiplying both sides to the power 2 over 3, we get x equaling 8 to the 2 over 3. Cube root 8, and then which is then squared, gives you x being 4. So that's the correct solution. Question 6. So the hints are just about to come up if you need them. So for part A, explain why 15 is not a sensible selling price for the toy. So just go and see whether you make a profit when X equals 15. Now part B, given that the company made an annual profit of more than 80,000, find the least possible selling price. Well, just bear in mind that we're told that P is measured in thousands of pounds. So when the profit is 80,000, that is in fact when P equals 80. So substitute in P being 80 and find X. Now for part C, the company wishes to maximize its annual profit. State according to the model the maximum profit that can be made. Well, this is the formula for the profit. We're trying to make this as big as possible. So it's 100 take away something. Now if we want to make this big overall as possible, okay, then we can go about making this second part here 0. Okay, we can look into what value of X will make that 0, and that's what we're going to look at for C part 2. But when this is 0, what profit do we indeed get? So when this is 0, what profit do we get? And then for part C part 2, we now need to look into making this part 0. Okay, so you need to go and solve this part here being 0. What value of X makes this 0? And then the solution for question 6. So for part A, why is £15 not a sensible price? So we're substituting in 15. We get the profit being minus 125. So obviously it would not be sensible selling the product for £15, as we would make a loss of £125,000. Now for part B, find the annual profit's 80,000. What price gives us this? So 80,000 profit, we're looking at the information here. Profit is measured in thousands of pounds. So we're substituting in P being 80. So 80 equals the right-hand side. So take away 80 from both sides, add this to both sides. It gives me this. I've then divided by 6.25. I've then square rooted. Okay, note I get the double selling price there. Okay, the two possible selling prices, add 9 to both sides. So I'm getting two possible prices here, but I'm being asked for the least possible selling price. So that's going to be 9 take away the square root of 3.2, which is £7.22. Now for C part 1, the maximum possible annual profit. So looking back at the profit formula that we've been given, okay, so the biggest profit we can make will be 100 take away nothing. All right, if we make it as big as possible. So 100 take away nothing is 100. So that is 100 P. P is 100. So that is £100,000 profit. And then what value of X will actually make this bit here 0? Well, that's when X is going to be £9, because obviously 9 take away 9 is nothing. Nothing squared is nothing. Nothing times 6.25 is nothing. So a price of £9 will maximise profit. A price of £9 will give us a profit of £100,000. Question 7. So the hint's just about to come up. So for part A, just draw a diagram to help you gather your thoughts. So A to B is 10, A to C is 5, and then the angle BAC equals theta. So there's two possible scenarios here, okay? It could be the red triangle or the black triangle with these two thetas. Now you're going to need to use the area of the triangle formula, and that will tell you what sin theta is. And then to work out what cos theta could be, remember that sin squared theta plus cos squared theta equals 1. Okay. And now for part B, find BC when it's the longest side of the triangle. So that's going to be using the ACB with the red theta. So you're going to use the cosine rule, and you're just going to have to decide which of the two cosine theta's values from part A is going to maximize the size of the length BC. So I'll leave it to you to ponder over which of your two cos answers for part A will give you the biggest length for BC. Okay, so the solutions for part 7. The area of a triangle is half AB sin C. And we know that A is 5, B is 10. We don't know the angle, but we know the area that we get is 15. Okay, so I've just gone and worked that out to give me what sin theta is. And then how do I then work out what cos theta could be? Well, I'm going to use the fact that sin squared theta plus cos squared theta equals 1. So substituting in, I get my two values of what cos theta is. And then for part B, find the exact length of BC, given that BC is the longest side. So I'm using the cosine rule here. A is B, B is 5, C is 10. And just looking at what I get when I cos theta either plus 4 over 5 or minus 4 over 5, I can see that I need to be using the minus 4 over 5. This gives me the smallest term here. So the biggest value for A, which is the length I'm trying to work out. So that's going to give me that A is the square root of 205. Question 8. So the hint is just about to come up. So for part AI, we've got to find the value of V that minimizes the cost. So to work out the maximum or the minimum, we want to differentiate. So first of all, get ready to differentiate. So rewrite the cost formula like this. So the V's gone upstairs. So 1,500 over V is become 1,500 V to the minus 1. 2V over 11 is 2/11ths of V plus 60. So go and differentiate that, set that differential equal to 0 to find a value for V. Now for part 2, find the minimum cost of the journey. So there you just need to take your value of V from part 1 and substitute it back into the original C formula. Now part B, well, it's telling you to work out d2c dv squared, so you differentiate the differential, substitute the value of V from part 1 into this second differential, and given that this is greater than 0, that you can conclude that this value of V calculates the minimum cost of the journey. So the solution for question 8. So we've got ready to differentiate, and then when we differentiate dc dv, we get this. So we've multiplied by the current power, reduced the power by 1. Now at the minimum value, dc dv equals 0, so set this equal to 0. So I've taken the V downstairs, so that's minus 1,500 over V squared, then added that to both sides. So 1,500 over V squared equals 2/11ths. So multiplying by V squared, dividing by 2 over 11, I get V squared being 8250. So V is 90.8 kilometers per hour. Now for part 2, I'm taking my 90.8, or in fact the exact version of this, and that's rounded, so the exact version of the answer, I'm substituting it back into the original C formula to get a cost of £93.03. Now for my second differential, I'm differentiating dc dv, so go back to this line here. So multiply by the minus 2, reduce the power by 1, gives me this. So minus 2 times minus 1,500 is plus 3,000, V to the minus 3, so over V cubed. So substituting in when V is 90.8 from part AI, I get dc squared, d2c dv squared, that's written wrong, that should be d2c dv squared, equaling a positive number. And because this number is greater than 0, I can conclude it's a minimum. Now stating one limitation of this model, well, for example, it would be impossible to drive at this speed constantly over the whole of the journey. Question 9. So just moving over to the hints. So for part A, we need to show that when we substitute -2 into the g function, we get 0. So substitute -2 into that and show that you get 0. Now for part B, in order to get it into this format, we're going to have to do the algebraic division. So we're going to divide the cubic expression by our factor of x plus 2. So work through that process and you will end up with no remainder because x plus 2 is a factor. And you'll end up with this quadratic. Then once you've got that quadratic, factorize that quadratic and you will find that it is a repeated bracket in the form of ax plus b. So we're going to have a repeated bracket when you factorize that. Now for part C, if you go and from part B, you've got your two brackets, so you can work out your two solutions. So we can see straight away from here our first solution would be -2, and when you've done part B, you'll work out that the second solution is indeed 5/2. So just relate our two solutions where it crosses the x-axis back to our original function. So this is the single solution where it crosses the x-axis, and just here where it just touches the x-axis, that is our repeated solution. So once you've got that, you're being asked to work out where it is less than or equal to 0. So either put down the specific points where it equals 0, or the range of points where it is less than 0. So 2 pieces to your answer for C part 1. Then C part 2, that is just a transformation of a graph. So remember, anything inside the bracket affects the x values but does the opposite to what you would expect. So rather than doubling the x values, this 2x is going to halve the x values. So your answers to part 2 will be half your answers to part 1. So moving on to the solutions. So up here top right, when we substitute -2 in, we do indeed get 0. But make sure to put in your conclusion that therefore x plus 2 is a factor of g of x. Now when I've done my long division in part B, I get 4x squared minus 20x plus 25. I've then gone and factorized that down here to get 2x minus 5 all squared. So popping it into this g of x format, I've got x plus 2, 2x minus 5 all squared. So from this, I've been able to get my two solutions for C part 1 of -2. And what value of x makes 2x minus 5 equal to 0? That's 2.5. So my two solutions are -2 and 5/2. Okay, so they're the actual solutions. So answering the questions for C part 1, where is it less than or equal to 0? Well, on this stretch of points here, it is less than or less than or equal to 0. So this stretch of points here is x being less than or equal to -2. So that is part of your answer. And your other solution is that pinpoint there where it equals 0. So just your second solution's got to be that x equals 2.5. So x is less than or equal to -2, or x equals 2.5. Now for part 2, it's got the 2 is inside the function, so it affects the x values opposite to what you would expect. So we're going to halve our x values. So where does it equal 0? It will be halving the -2 to get -1, and halving the 2.5 to get 1.25, 5/4. Question 10. So the hint is to follow. So the formula booklet tells us this here. Okay. So our first line of workings is to substitute into this formula here, where our f of x is x cubed. So this part here, this f of x is our x cubed here, and this bit here is our x plus h all cubed. So be very careful that you're comfortable that term there you're happy with, okay? It's your x plus, your function is your x plus, whatever the function is, plus h with inside the function. So it's x plus h all cubed, not x cubed plus h cubed or something. So from then onwards, it's just a it's just algebra, okay? So multiply out that bracket by itself, take away x cubed. You'll find then that the x cubed terms disappear. So all the terms in the numerator have got an h in them. And then when you divide through by h, it will eliminate some of the h's, and then you take it from there. So the solution for question 10. So this is the gradient of the chord, x plus h all cubed minus x cubed over h, just substituting into the formula given in the booklet. Now just here, I'm just working through the expansion of the brackets cubed. So when x plus h times x plus h gives me x squared plus 2xh plus h squared. Then multiplying that by x plus h again, I get this, which simplifies to this third line here. So the gradient of my chord is my x plus h all cubed. So I've just repeated it here. It's the bit highlighted in yellow. Take away the x cubed all over h, and you will see that the x cubes cancel. And you will see that h is common to all of the remaining three terms in the denominator. So the gradient of the chord, each of these three in turn, is divided by h, giving us 3x squared plus 3xh plus h squared. Now, you've got to be very precise with your notation here. So write down as h approaches 0, our second and third terms will start approaching 0. So overall, as h approaches 0, we're approaching 3x squared. So you've got to write down as h approaches 0, 3x squared plus 3xh plus h squared is approaching 3x squared, and therefore the differential of x is 3x squared. Question 11. So just about to give you a tip if you need it. So this is the formula from the formula booklet. So just comparing this to the question, our a is 2, our b is minus x over 16, and our n will be 9. So just simply substitute those three things in. And note that it's just asking for the first three terms. So it's going to be that term, and that term. Now, for part B and part C, given that the first two terms in ascending order of x in this series expansion are this and this, find A and B. So what we've got going on here is we've got A plus bx multiplied by the expansion that you've just done in part A. So this was the expansion you got from part A. Okay, so for part B, we're just looking for the terms where you're just getting normal numbers. A is the normal number coefficient. So the only way we get a normal number coefficient, and where it is the A times the 512. That's the only clause that will give you something that doesn't have x's in. So A times 512 will equal our 128. Now for part C, we're trying to find out where we end up with x's. So we get x's when it's the a multiplied by the minus 1 for 4x. That will give us x's. And where it's the bx multiplied by the 512. Both of those branches, both of those clauses give us x's. So that plus that, the coefficient of that plus that, will equal 36. And the solution for number 11. So we're substituting in a being 2, b being minus x over 16, and n being 9. So it's 2 to the power of 9, n choose 1, 2 to the power of 8 times the minus x over 16, then n choose 2 to the power of the 7, multiplied by minus x over 16 all squared. Now remember, 9 choose 1 is just 9 over 1, which is 9. 9 choose 2 is 9 times 8 over 1 times 2. So that gives us that. Those are the so what does it ask us to do? Find the first 3 terms. So those are our first 3 terms for part A. So for part B, okay, we've got a plus bx, and we're multiplying it by what we've just worked out in part A. So a times 512 is our 128. So 512a equals 128. Divide by 512. We work out that a is a quarter, which is the answer for part B. And then for C, we've got the double claw, haven't we? For C, we've got the double claw. We've got where do we get our x's? It's whereas a times minus 144 gives us minus 144 ax. Our minus 144, and then our second claw giving us x's is the bx times 512. So our coefficients of x's are the minus 144a and the 512b, and these together give us the 36. So we've got minus 144a plus 512b equals 36. We know our a from part B. Substitute in, we can work out that b is 9 over 64. Question 12. So I'll just give you a tip if you're a bit stuck where to start. So for part A, the first line of workings, we're going to replace the tan theta with sin theta over cos theta. Okay, and then multiply that out. So you can have a sin squared theta over cos. And then what I suggest you do as your second step, in order to undo this dividing by cos, go and multiply both sides by cos theta, and then take it from there to try and get to what we need. Now for part B, you've just got to pick up what's going on here, okay? We've got to solve this here, okay? And that is obviously effectively that top line there, just with theta being replaced by 3x. So in solving this with 3x, we're really solving this with 3x. So our first line of workings is just to replace this with 3x. And then we've just got a normal quadratic, haven't we, where cos 3x is effectively our y. So go and factorize and solve that. And then using a cast diagram, go and pick up all the various solutions. So the solutions for question 12. So for part A, replace tan theta with sin over cos. Multiply through by cos theta, we get this. Now we've got both terms on the left hand side involve cos theta, so let's go and replace the sin theta term with a cos theta equivalent. Then everything will be cos theta. So looking at the bit in red, because sin squared theta plus cos squared theta equals 1, rearranging that, sin squared theta equals 1 minus cos squared theta. So going from this line to this line, I've just replaced the sin squared theta with 1 minus cos squared theta. That I've multiplied out the bracket on the right hand side, set it equal to 0, and we get what we have to solve. Now for part B, the new equation we've been given here is effectively the opening equation with theta being replaced by 3x, and we're told that that can be written in that format, so we can rewrite part B in this format, replacing theta with 3x. So our opening line is this line here. Now we can factorize that. Okay, you might be able to do that just by trial and error. I can't. So that's my workings over here inside the green rectangle, where I've just, for ease, replaced cos 3x with y. So I'm having to solve 6y squared minus y minus 2 equals 0. Ignore where it's saying cos y there. That's a mistake, isn't it? Let's just take that out if I can. Right, that shouldn't be cos y there. Okay, so factorizing that there. Okay, we have factorizing that there. What two magic numbers multiply to be 6 times minus 2, which is minus 12, yet add to be the minus y, the minus 1. That's 3 and minus 4. So replace the minus y with plus 3y minus 4y. Fully factorize the opening two terms, fully factorised terms 3 and 4, we get this. And our final pair of brackets is the 3y and the minus 2, and then the repeated bracket. So then replacing the y with cos 3x, I get my factorised solution over here on the left, highlighted in orange. So what value of 3x cos 3x makes this first bracket 0? That's when cos 3x is 2/3. And secondly, makes this second bracket 0. That's when cos 3x is minus 1/2. So I'm going to let my cos 3x equal capital X. I've changed my boundaries, so I needed all the solutions between 0 and 90. So timesing them by 3, my capital X solutions are between 0 and 270. So I'm solving cos capital X equals 2/3 from my calculator. That gives me the one solution of 48.1 within 0 and 270. Now with cos x being minus 1/2, so cos is negative, I'm picking up these two solutions here, okay, which are the 120 and 240 solutions, 120 and 240. So those are my capital X solutions. To get my lowercase x solutions, I need to divide by 3. So from the 48.2, I get the 16.1. And from the 120 and the 240, I get 40 and 80. So those there are my 3 solutions. Okay, just going back to this earlier on, okay, cos x equals minus 1/2. I got my opening solution by doing inverse cos minus 1/2. Question 13. So your hint for this. So for part A, start with the exponential formula we've been given, v equals pq to the power of t. And then using your log understanding, okay, you need to rearrange this into this format here, which ties in with y equals mx plus c. So you can see our y, there's our y, which is our log v, our y-axis. There is our t, okay, which is our x-axis. So as y equals mx plus c, so log q is our gradient, okay, and the question tells us that the gradient is 0.05. So log q equals 0.05. So from that, use your log understanding to work out what q is. And then back to this, y equals mx plus c. Our log p is our c, which is 4.8 from the question. So log p equals 4.8, so go and solve for that. Now for part B, with reference to the, part B, I'm leaving for you to go and figure out for yourself. Okay, not giving you any hints on that. Now for part C, find the value of the painting as predicted on the 1st of January 2010. Now we started off on 1st of January 1980, so this is 30 years later. So T equals 30. You know your P and your Q from part A. So you know P, Q and T, so you just substitute in to find your V. So here follows the solutions for question 13. So for part A, start off with V equals P, Q to the power of T, log both sides. Then using the multiplication rule, the right hand side becomes log P plus log Q to the power of T. Using the power rule, the right hand side, your second term becomes T log Q. And then I've just rewritten it the other way around, so it makes it more into the y equals mx plus c format. That ties it in with the question. So my m 0.05 from the question is my log q, so log q equals 0.05, and my c, my log p, is 4.8 from the question, so log p equals 4.8. So therefore q equals 10 to the power of 0.05, which is 1.122, and p equals 10 to the power of 4.8, which is 63100. Both of these are to 4 sig figs. Now part B, with reference to the model, interpret the value of the constant P. So P is the So P is the value of the painting on the 1st of January. Okay, so we're saying that P is the when T is naught. When T is naught, so on the from the 1st of January, Q to the power of naught will be 1. So when T is naught, V equals P. Hence why the value of the constant P is the value of the painting when we started on the 1st of January. And the 1.122, which is our Q, is the M. Okay, it's our M. And that's the gradient. So that's our proportional increase each year. Okay, so the value of P is our C, all right, or log P is our C. So P is the value of the painting on the opening day, and then our constant Q is the gradient. Our log Q is the gradient. That is the proportional increase each year. Now for part C, find the value of the painting as predicted on the 1st of January 2010. Well, that's 30 years later, so T is 30. We've worked out P and Q from part A of the question, so we know P, Q and T. Substitute the 3 in, we can work out the value of the painting to the nearest £100,000 is 2 million. Here's the question 14. So just pause it now if you want to have a go with no hint. So your hint for part A is that you need to go and rearrange this so you have your x terms followed by your y terms, then go and complete the square for x and y and get it into this format. Once you've done so, the center of C is AB and the radius is the square root of your right hand side. Now for part B, the line with equation y equals kx cuts the circle at 2 distinct points. So wherever a circle and a line or any two things cross, you want to solve the simultaneous equation to find those solutions. So the equation of our line is y equals kx. The equation of our circle is this here. But now, of course, we know what A and B is, having done it in part A. So just go and substitute in 1 into 2. So go and replace your y value, your y here, with your kx here. Then multiply out the pairs of brackets, set it equal to 0, and get it into quadratic formula. So you've got your x squareds, your x's, your normal numbers equaling 0. That will give you your A, your B, and your C. And because we've got 2 distinct solutions, the determinant, okay, will be b squared. The b squared minus 4ac will be greater than 0. So set it greater than 0. Solve that inequality, and that will give the range of values for k. The solutions for question 14. So multiplying, popping your x terms together to start with. Top right we are here doing part A. So I pop my x terms together, my y terms together. I've then completed the square for x squared minus 6x and y squared plus 10y here. And then gather up your minus 9, your minus 25 and plus 9 and take it to the right hand side. We get it in this format. So the center of our circle is 3 minus 5. And the radius is the square root of the right hand side is 5. So we've got our equation of a circle ready for part B. Okay, it's this x minus 3 all squared plus y plus 5 all squared equaling 25. Now where does that cross the line y equals kx? Well, we have a simultaneous equation, so I'm going to replace my y with kx. So I've just substituted the kx into where y was. I've then multiplied out again and multiplied out, gathered up my like terms. So I've got my coefficients of x squared, my coefficients of x, my normal number equaling 0. So my A is 1 plus k squared, my B is 10k minus 6, and my C is 9. So using b squared minus 4ac, because I have 2 distinct points, This is greater than 0. So my b squared is here, minus 4 lots of a times c being greater than 0. Multiply out and simplify, factorize, I get this. Okay, so I've got my solutions at k being 0 and k being 15 over 8. Then I've just gathered my thoughts. Okay, this is a positive quadratic. So I want all my solutions where I've got which are greater than 0. So it's this set of points here and here. So it's wherever k is less than 0 and where k is greater than 15 over 8. Question 15. So there's quite a lot going on here. It's a 10 marker. So give it some thought, and if you need a hint, just move on to the next bit. So we've got to work out the area of the shaded area R. Now to do this, we're going to work out the area of this triangle on the right that I'm calling A to B to P. And then we're going to add on this area under the curve to the left of that dotted line. Okay, now in order to work out the area of this triangle to the right of the dotted line, I just need half times base times height. So I know the height because it's going up to 4, 6. I know the height is 6. So I know that A is at 4, but to work out the length of AB, I'm going to need to know where the line crosses at B. I'm going to need to work out the coordinates of B. Now to do that, I'm going to have to work out the equation of the line PB, set that equal to y being 0, okay, and then I'll be able to work out the x coordinate of B. Now how do I work out the equation of a straight line? Using the y minus y1 formula, I need to know a point on the line. Well, I know that, it's 4, 6, and I need to know the gradient. Now how am I going to work out the gradient of this line? Well, this line is a tangent to the curve. So if I could work out, this line is the normal to the curve, So if I could work out the tangent to the curve when x is 4, I could flip it over and change the sign and work out the normal to the curve, and then I'm away. Okay, so let's just go through all of that again. How am I going to work out the tangent of the curve at 4? I'm going to need to differentiate the curve, substitute in the x coordinates of 4 to work out the tangent at P, flip it over and change the sign to work out the gradient of the normal at P, substitute that into the y minus y1 formula along with our knowledge that the point P sits on the line, and then using that equation of a line, B is when y equals 0. That will give me the value of B. I can then work out the area of the triangle, half times base times height. Now, to work out this other part of the area under the curve, I'm going to need to integrate my original curve, integrate it. So get it ready to integrate and integrate it, and then set that between the values of 4 and 2. So the solutions for question 15. So our area R comprises this triangle APB and this area under the curve from 2 to A, from 2 to the value of 4. So the area of the triangle ABP is going to be half times base times height. I know the height is 6. I need to work out the length of the base from 4 to B, so I need to work out the point B. Okay, so to do that, okay, I'm going to go and differentiate the curve. So I'm going to get it ready to differentiate. So y equals 32x to the minus 2 plus 3x minus 8. Differentiating it, I get this. I'm substituting in when x equals 4, giving me a gradient of the tangent at P. So the gradient of the tangent to the curve at P of 2. Therefore, the gradient of the normal at P is minus a half. So my equation of the line L, of the line going from L to going from L to what I call B, the equation of the line L, I know one point on the line, which is 4, 6, and I know the gradient of L is minus a half. So substituting that into the y minus y1 formula, I get this. When I tidy that up, I get y equaling minus a half x plus 18. plus 8, excuse me. So at this point here, okay, I go and substitute in with y being 0, and this gives me an x value of 16. So this value here, which I've now called q, sorry, it's a bit confusing. I called it b back here, didn't I, on the hint, but I'm now calling it q. So that point there is 16. So the area of my triangle, half times base times height. The base goes from 4 to 16. So that's half times 12 times the height of 6, which is 36. So that's the first part of my area, which I'm calling R1. I'm calling R2. I'm calling that R2, the area of the triangle. Now, I think in a way, the area of R1, the area under the curve, is easier to understand. We're just going to integrate the curve between 4 and 2. So go back to the original curve, get it ready to integrate. So add 1 to the power, divide by the new power, okay? And I get this. And then I substitute in for 4, substitute in for 2, take 1 away from the other, and I get an area for R1 of 10. So my overall answer for the area of R is R1 plus R2, which is 10 plus 36, which is 46 as required.